between any two objects is directly proportional to the product of their masses and indirectly proportional to the square of the distance between them.
C squared?
The square of the
Distance between them.
yeah.
Okay, can you resend that whole thing?
Tell me what you have written down.
It's directly proportional to the product
Of their masses. Okay.
So that's just the definition of it.
Yeah. Now, remember, in that definition, you need to know which one's inversely and which one's directly. Now, this is going to be the formula for it. Force is going to equal to cap G. This is not gravity, by the way. Or not gravity in the sense of 9.8 meters per second squared. It is gravity. But I'm going to show this in just a second. Times mass 1 times mass 2 over r squared.
She said, see you in the car.
Now, when I say it's directly proportional, this is the force that we're talking about from the definition. When I say directly proportional to, again, that's talking about what's in the numerator here. And when I say indirectly proportional, that's what we're talking about in the denominator here. Because how do you increase the value of a fraction? You increase its numerator, right? And what can you increase to decrease the value of a fraction? The denominator. So that's the reason it's indirectly proportional. If I want to increase the denominator, I'm going to decrease this force. If I'm going to increase this product, then I'm going to increase this force. So if you ever get on a test and you don't remember the exact definition, and the definition is one of those that's set up where you have a parenthesis there and it says, I have directly and indirectly written in the parentheses, and you want to figure out which one to circle, think about where it is in the equation. If it's in the numerator, then it will be directly proportional, and if it's in the denominator, it will be indirectly proportional. Now, G is the gravitational constant. And the gravitational constant is going to be 6.67 Newton meters squared per kilogram squared. I'm sorry, whoa, hold up. If you wrote that down, scratch it out.
Are you kidding?
I left something important out. That was just messy. I left the times 10 to the negative 11 out. That would make a big difference.
Yeah.
If we didn't have that in there, that means we couldn't walk around this room without just being drawn into someone.
What type of motion is this?
This is not really a motion, it's a gravitational pull.
So,
G stands for gravitational pull?
Yeah. If you, what it's saying is this. If I have two heavy steel balls hanging down from a string, and they're really close to each other, they're going to pull in and touch each other. Even if they're not. If they're a close distance apart, there will be a gravitational attraction between the two that will actually pull them in and have them touching each other.
Is that how race cars are?
What now?
Is that how race cars are when you be drifting?
Drafting? No, we'll study a little bit more about that. That's they're touching each other because the drivers are making them touch. Now, I'm talking about just two free hanging. I'm thinking about wrecking balls. Just two big wrecking balls that are there that are real close to each other. They'll pull in and actually touch each other. So let's take this and consider it in a problem, okay? Let's go with this question. What is force of attraction between two five-kilogram balls now what is the gravitational acceleration? Gravitational attraction, I should have said.
Scientific force?
What now?
They're the same word as force?
Yeah, the gravitational fraction is, the gravitational attraction will be a force. Never fear, I found the book. All right. Let me clear one other thing up, too. When I said the square of, in the definition, when I said the square of the distance between the two, what I meant was between the two center of masses. So if you want to add that to the end of the definition, you can.